Okay, guys, we made it to Unit 3, Trigonometry. And to do that, we're going to start with an intro today on periodic phenomena. And so here is some vocab to start this unit. It tells us a periodic relationship between two variables occurs when the output values demonstrate a repeating pattern over successive equal length intervals. It's also called cyclical. So we've got a pattern for a certain amount of length, and it will repeat itself forever. That's a periodic graph. The period of a periodic function is the length of the x values that it takes for the function to complete one full cycle. So looking at this graph here, f of x, we can complete one full cycle from here to here. The graph increases, it's constant right there, decreases, and then the cycle begins again. So we're going to start increasing, constant, and then decreasing. Now, from here, the beginning to the end of that one cycle, we said that's 1, 2, 3, and 4 units long. So the period is 4 units. That's what it takes to repeat. So it tells us a function f is periodic with a period of 4. A portion of the graph of f is shown above. Draw 2 additional periods for the graph of f on the axis above. So I would repeat the same cycle, and it would happen within 4 units again. So I know it starts right here. So at 4 units, it's going to be right back at that same spot. And then another 4 units, and it will return to that spot again. Now, in between these two, I know all of this needs to occur. So from here, it went 2 to the right and then up 2. So I would go 2 to the right and up 2. And then it was constant for 1 full unit, and then it decreased. So I've repeated that cycle. And then we do it again, 2 to the right, up 2, constant, and then decreasing. And so we've just added 2 more cycles to that graph. This is a periodic function. This period repeats over and over again as it continues forever. Here's another example of a periodic function. It tells us a portion of the graph of the periodic function g is shown above. What is the least possible value of the period of g? So we're looking for where do we get one full cycle of this graph. You can start at any given point really to measure that out, and then when it starts to repeat would be the end of it. So it started right here, I can say, and then it went down, up, constant, and here starts that down again. So the period would be this portion right here before it repeats into this next cycle. So I count that out. That would be 1, 2, 3, 4, and 5 to get to that point. So we would say the period of this graph is 5. All right. On these following questions here, we're going to continue to use that graph of g of x. And it says, using the function g and the period found in example 2, find the following values. So g of 14 is not on this graph, but since I know it repeats every 5, I can think through that. And we're going to look at that a couple different ways. And so the period is 5, so I know every 5 it's going to start again. So if I started right here, 5, 10, 15, and so on. So 14 is less than 15, but bigger than 10. So I could say 2 full cycles will occur in that 10, and so we can start right here at 10. Then this would be 11, 12, 13, and my 14 value would be right here, which is 7. So that's one way of looking at it. I just looked at it graphically on the graph. I think through those cycles, what's happening. Another way you can think about that is we know a period happens every 5 units. So I can say 14 minus 10 is 4. So this is going to be the same thing as g of 4. Because 10 would give us the 2 full cycles, and then this is that remainder part. And so at g of 4, I go to 4, and there it is at 7. So you can look at that a couple different ways. Again, some of the numbers can be bigger. You just need to think about how many times there. So we know that 5 can go into 72, all the way up to 70. So I can say this right here would be my 70, then my 71, and then my 72 is right here at 6. So if I look at it graphically, that's what I would do. I know 5, 10, 15, so on would get all the way to 70 with a full number. So this would be my 70. 71, 72, which is what we're looking for in this case. Again, we can think about it also as 72 minus that 70 is 2, so we would have a remainder of 2. You could divide it, 72 divided by 5, and you would have a remainder of 2. So we're looking for G of 2. And so I go to G of 2, and that is 6. So there's a couple ways you can approach these problems. All right, for G of negative 17, that means I'm going backwards this way to find that value. But I can still do the same exact thing. So I could say negative 17 plus 15, because that's how many cycles would go through there, is equal to negative 2. And so now I'm back on the graph right here at negative 2, it is 7. All right, let's look at another one. So we're going to get a little bit deeper into the definitions here. It says the function of f shown below is periodic. One period is graphed. Use the graph of the to answer the following questions. And so the first thing I want to look at this, it says 1 period, which tells me that from here to here is 1 full cycle of this curve. That's 1, 2, 3, and 4. The period tells you a lot about the graph, so I would look at that first. So I'm going to make myself a note there. That's a period of 4. Now, wants to know, is the graph increasing, decreasing, or both over the interval 18 to 20? That's not on the graph, so we're going to have to think about what the cycle looks like from 18 to 20 on that interval. Now, just looking at this graph right here, we can see this part right here is decreasing until it gets right here and then increases. So we need to know on this cycle from 18 to 20, are we on this side of the graph or this one, to be honest? All right. One of the ways we can do that is I can say f of 18 and then f of 20, and I can find those values. So we can do that exactly the same way we did it on the last one. This is a period of 4, and so I can do that 4 times in here to get it to 16. So this would be 16, this would be 17, and this would be 18 right here at negative 2. And then this would be 19, and this would be 20 at positive 2. Did I go too far? Sorry about that. 18, 19. So let me correct that real quick. Okay, I did count those right. F of 18 would be at negative 2, F of 20 would be 2. So we're talking about this graph right here, this portion of the graph. And so this is the portion that is increasing. So my answer would be it is increasing. And if we want to be specific, which we do, we would say over the interval 18 to 20. All right, the next question says, is the graph concave up, concave down, or both on the interval from 31 to 33? So we're bringing back these vocab words from Unit 1 here. So concave up would be in this situation right here. Concave down would be if it is on this portion of the graph or this one, because remember, this does continue. It would look like this on this side and this on this side. So this would be my concave down. This would be my concave up, concave down, and so on. So we need to see which portion of the graph again would be from 31 to 33. Since the period is 4, I can get all the way to 28 with 4. So I can say it starts over again right here at 28, 29, 30, 31. So f of 31 is equal to 0. F of 32 would be my 2. And f of 33 would be my 0. So 0 to 0. We know that portion is concave down. So the graph of f would be concave down on the interval 31 to 33. You really need to picture the graph, maybe come up with the values here so you can see exactly what's happening for those. All right, so let's go back to some more of those vocab words from Unit 1, relative min and relative max. Remember, relative means that it is a minimum or a maximum on that portion of the graph. So this would be a relative max on that portion of the graph. This would be a relative min, relative max, and so on. So we want to know where that lands at x equals 82. So we're looking for that f of 82 point. Again, our period's 4, and so we can get all the way to 80 with 4, and that would leave us with that remainder of 2. So this would be the 80, 81, and 82. And so that is the y value, -2. That would be this portion of the graph right here, and we know this is a relative minimum. These questions are not hard, but you do have to think through what is occurring, what that period tells you, what that cycle tells you, and then go back and think about our vocab words from Unit 1. All right, on our next example, we're always looking to do the different representations. So we've looked at those in graphs and algebraically, basically. Now we want to look at it from a table standpoint. So it tells us that the graph of H is periodic and it has a period of 5. So right here, they're telling us that there is that pattern that continues, and it continues every 5 units. We're going to see another cycle of that. The values of H are shown at the selected values of X. So if we're looking for H of -2, that's not on my table right here, but I know that the period is 5. And so 5 units from each one of these would be the same exact values. Let's think about that. So 5 units from 1, 6, for example, just wrote H. 6 would be at -2 because that is 5 units from this. 5 units from 3, so 8 would be at 0. So you can come up with a couple other values from there. Now, here it gives us specific values we're looking for, -2. So I need to think about which one of these values is 5 units from -2. Well, that would be 3. If I went to the left 5 units, I would be at -2, and so that is 0. Well, this one, kind of a cheat, we already did that one right there on the table, is -2. All right, so this one, they just did a composition with it, which we saw in Unit 2. It says H of 9. So the first thing I would want to work is this inside part. So I need to find H of 9 first. Again, 9 is not one of the ones on here, but 4 is 5 units from 9. So that would be a value of 3. So then we get H of 3. And that one's right there on the table. So that would be 0. All right, this one here looks scary, but it is actually not. It says 5k minus 3. This right here we know is the period. And since that's basically the slope there, we can see every 5, it is changing by that. So all we need to do is find H of -3. And so for -3, we want to go 5 units from -3. And so if I went from 7, 5 units down would be 2, and then 5 more units down would give me that -3. So that's the one that has the same value of 2. All right, so it says, it is useful to have notation to model this phenomena. A periodic function starts with a basic pattern and then translates that pattern repeatedly over its domain. As a result, we are able to consider a periodic function as a horizontal translation of itself. In example 5, the period of H was 5, meaning that we could translate the graph of H horizontally 5 units and end up with the same exact graph. This means that the function H satisfies the following equation. Remember when we talked about transformations, this right here was a horizontal translation of 5 or by 5. So that was going to the right. And so what this is saying is that you can move this to the right or even to the left and end up with the same graph. So let's look at those examples so you can see what that means. So here is my period. In this case, the period was 4 units. But if I took this and I moved it to the right 4, then this portion of the graph would land here, and this one would land here, and that one would go there. So we would end up with the same exact graph. So these periodic graphs are actually a horizontal translation. You can get the same exact graph. All right, so let's see another one now and think through that with the translation. Here we have the graph of f. It tells us the graph of f is periodic with a domain of all real numbers. 2 full periods of f are shown. Find all input values of f that yield an output value of 1. So we're talking about 1, which is this value right here. The first thing I want to do is always get that period. It tells us so much about the graph. And so from here to here would be a cycle. I would be up and then down and up and then down and so on. So that's 1, 2, 3, 4 units. So I know that the period of this graph is 4. And so now I want to find the x values that give me this point right here. And so I see that point is at 2. So I want 2 plus the period is 4. So that would be 4 times every integer. We want to write there where k is an integer because technically if we put 0.5 in here, that's not going to give me the correct answer. So we do want a whole number to be in there. But if we put in 1 here, that would be 2 plus 4, which is 6, and you'll see that right here. If we put a -1 right here, that would be 2 minus 4, which is -2. And if I went 1, 2, 3, 4 over here, it would be back at that 1. So this gives me all of the places that this function has a value of 1. All right, it's time to start talking about some of these FRQs. On the AP test, you're going to see FRQs. And so we are getting closer to being able to do those full FRQs. So we're going to look at an example here. It tells us the figure shows a large clock mounted to a vertical wall. The clock has an 8-inch long moving minute hand. The center of the clock is 120 inches directly above the floor. So I'm going to go ahead and label that as 120, and that's inches. Because it says the center of the clock is above the floor. So our center right here would be the 120. At time t equals 0 minutes, the minute hand is pointed directly up at the 12. However, the clock is not working properly and the minute hand is moving twice as fast as it should. Thus, the next time the minute hand points directly up at the 12 is at time equals 30 minutes. As the minute hand moves, the distance between the endpoint of the minute hand and the floor periodically decreases and increases. All right, let's go back and label a couple other things that I saw in here. So it says the clock has an 8-inch long moving minute hand. So this right here is 8 inches. And so it's telling us that it's increasing and decreasing its distance. Well, when this is at the top here, we could say it's 128 inches because 120 to get to the center plus the 8. Then it starts to go down until it gets right here at 112 inches because this is 120 minus the 8 would give me the 112. And then it starts to go back up to the 128. And then it will continue every time it goes around doing that. All right, so the first part of our FRQ here says the periodic function h models the distance in inches between the endpoint of the minute hand from the floor and the floor as a function of time t minutes. The graph of h and its dashed midline for 2 full cycles is shown. 5 points, F, G, J, K, and P are labeled on the graph. No scales indicated and no axes are presented. Determine possible coordinates of T, H of T for the 5 points F, G, J, K, and P. So we want to come up with the coordinates for these points right here. Let's go back to our picture real quick and talk about that. We said when it starts right here, when T is equal to 0, it tells us at time T equals 0, The minute hand is pointed directly at the 12. So that's at the highest point, which we said was 128. This would be my highest point in the pattern. So I'm going to say this is 0, 128, because that's the tallest part. Now, if this was a regular clock, I would say P would be 60 minutes as it went completely around. But remember on here, it said the next time the minute hand points directly up to the 12 is at T equals 30 minutes. So when it's back up on top right here, it's been 30 minutes. So what do you think this is going to be? Well, that's going to be time 30 minutes, and it's going to be back at that height of 128. Now, in the center of these two, that's on my bottom point. So that's going to be when it's at the 6 right here, my lowest point. This is the highest point, and then this is the lowest point, and then it keeps going. Well, that's at half the time there. So I can say J would be 15, and we said 112 minutes. Then we can come up with these 2 points. That is directly in between these. That's when it would be at our 3 hand, and this would be at our 9. So let's go ahead and fill out those points. So in between these, that's 0, that's 15. So this would have to be 7.5. And then it would be at the very center of our height, which we said was 120. And so if this is 7.5, all I have to do is add 7.5 to this. So we would get our 22.5. And at the center again is 120. So now we've labeled all of the points. This is the first portion of that FRQ, so you have to be able to label those points. It takes a little bit because you have to read through the information really well and think through everything that they are telling you so that you can find that input value and that output value for each of those. All right, as we refer to the graph, right here I am going to go ahead and tell you that let's say on the test you can't come up with those 5 points. Do continue on because you should still be able to answer some of these other questions even if you can't answer that. And you never want to leave something blank that you could have answered. It says refer to the graph of H in part A. The t-coordinate of G is T1 and the t-coordinate of J is T2. So we're talking about these 2 points right here. This is G, this is J, and it's saying these are the time interval that we're looking at. So 7.5 to 15. So we're looking at this portion of the graph. On the interval T1 to T2, which of the following is true about H? So in this portion of the graph right here, which one of these is true? Well, all of these values are positive. There's no negative values, so we can already cross out both of these. So we're deciding between, is it positive and increasing or is it positive and decreasing? Well, our graph here is going down. It is decreasing. And so this would be B. Even if I didn't know these points, I should be able to look at the graph and know that this is positive and that it is decreasing. All right. The last part here says, describe how the rate of change of H is changing over the interval. I can also answer this question. We're looking again from T1 to T2, which we described as G to J. And it's asking us what the rate of change is doing, not what the graph is doing, what the rate of change is doing. And we know that comes from our concavity. Well, this is concave up here. And so we know when it is concave up, the rate of change is increasing. So we can say the rate of change is increasing because the graph is concave up over the interval T1 to T2. And again, you could have done that without knowing the points either. So answer all the questions that are possible. That was our first FRQ practice. We'll see more of those as we go through the unit. Bye.